Right. So the question is, who was Alfred Wegener? Wegener, it starts with a v sound because he was from, where do you know? He's German. He was a German scientist. So it's not Wegener, it's Wegener. Okay. Who was he? Go ahead and get us started. Can you say it really loud for me? Yeah, he was the first person to have the idea of continental. Let me see if I can spell. Yeah, go ahead.
He created the theory of Pangea.
Yep. Other things you got about him? Quick question. Let's go back and make sure we understand these things. We've talked about this one already a little bit, but what is Pangea? It's the continent with all of the continents put together, right? They called it a supercontinent, right? When all of those continents fit together, that was the thing that you cut and pasted out yesterday, right? Okay, so just to make sure you know that, you got this in your capture questions. So Pangea is that supercontinent. Okay, that included all of the continents in one. And the other thing he's known for now is continental drift. What is that?
Continents drift.
It's true, right? Right? A little bit of a circular answer, but the continents drift. Livia, what did you say? Yeah. The movement or drifting of the land masses, right? The idea that at one point in our Earth's history, all of the land masses were together, and now they're not. We don't really call it continental drift anymore. We've developed the theory a little bit more, and now it's called, does anybody know what it's called? It starts with it's two words, P and a T. Plate tectonics. Plate tectonics is the theory that was built out of continental drift. Alfred Wegener was the very first person to ever come up with this. And friends, everybody thought he was nuts. Okay? He was shunned. They were like, that's terrible. It wasn't until 30 years after he died that they, kind of acknowledged that it might be right. He's so famous that they wrote a song about him. It's a pretty great song, so I'm going to play it for you real quick.
Yay!
No, you'll love it. Extra points for dancing. Oh. No. Sorry to disappoint. Hold on just a second. Let me turn up my sound so you can hear it. You don't believe this is an actual song? What? Come on, Haley. Where's your faith in me, babe? That what'd you say?
Absolutely not.
This is absolutely a song. It's on YouTube. It's got to be true. In fact, the Amoeba people made this song.
Well, they're crazy.
Well,
The Amoeba people are my favorite.
I know. It's your favorite group. Right? There you go. Now listen to it.
In the year of 1910, there was a scientist whose name was Alfred Wegener. He noticed that the continents looked just like pieces of a broken puzzle. By 1915, he called it continental drift. It caused a rift with his fellow scientists who sang, Alfred Wegener, you are a crazy man. Alfred Wegener, you are a crazy little man. or why you merely have one interesting hypothesis. Until this evidence we see, you don't have a theory. Alfred Wegener, you are a crazy man. Alfred Wegener, you are a crazy little man. In the year of 1930, on an expedition to Greenland, Wegener got caught in a blizzard. When they finally found him, it's much too late, and they buried him in an icy mausoleum. 30 years after he died, a new idea came to light. It changed the way geologists saw the world and brought continental drift back to life. Now everybody sings, yeah, Alfred Wegener, you are a brilliant man. Yeah, Alfred Wegener, you are a brilliant man. Continental drift, Alfred Wegener's theory, continental drift. Alfred Wegener's theory, continental drift. Alfred Wegener's theory, continental drift. Alfred Wegener's brilliant theory.
So I will put a link to that on Canvas in case you need to watch it over and over and over because it's pretty awesome. It's adorable though because half of you are like rocking out and then others of you are like, I can't believe that they made this. But regardless, you're welcome. Well, here's the thing though, if every other earth science teacher showed their students and then you guys were the ones that hadn't seen it, you'd be like, I heard that we saw this really great music video in class. How come you didn't show me? And then I would not hear the end of that. So I just want everything to be equal among you all, okay? Now, I know you're right. You're welcome. And most of them watched it last time, so anyway. The other thing is, well, number one, it's going to stick in your brain forever, so you're welcome for that. Number two, it tells the story of Alfred Wegener very concisely, okay? So I'm going to give you just 2 minutes, maybe 1 minute and 30 seconds. I want you to write down real quick underneath your question of who is Alfred Wegener. Yes, he came up with continental drift. Yes, he came up with the theory of Pangea. Tell me a little bit more of the story right now. Move your pencil on your paper. Tell me the story right now. Go. Now I'll answer your question in just a second. Is that okay? Yes. Okay. So write it down. This is you and your paper and your pencil, your brain. Those are the things involved right now. Give me another 15 seconds. That was fast. All right. So who was he? Tell me the story. Tell me a little bit more. What's another piece of the story that you caught from the fantastic music video that you listened to? Yes.
No one believed him because he didn't have evidence.
Right. So that's a really important piece, right? So when he first developed the idea, no one believed him. Because he didn't have evidence. In order to have a strong scientific theory, not only do you have to have an idea, an explanation of what happened, but you also need to say, here's some stuff that I can use to show you that it's actually true. Yeah. No one believed him because he didn't have any evidence. Where did he come up with the idea in the first place? Yeah.
He noticed that the continents of like puzzle pieces, he suggested that they were all one.
Yeah.
That they're at one point.
So the puzzle pieces of continents led him to the understanding or the idea of continental drift. And that's a big thing in science, right? Like when you're first coming up with an idea, it might just be a spark from something that you see, like, oh, that's kind of interesting. Maybe that's a cause, right? Or maybe that's what happened. But until you can actually get the evidence, then you're kind of in trouble. He was never able to come up with any evidence, right? Prior to any other evidence, what happened? Tell me more of the story. What happened to poor Alfred Wegener? Go, Haley.
He died.
He died in a blizzard where? Greenland. Yeah, I got to watch it carefully. They even had a pencil that was underlining it, right? Yeah, so in Greenland. What was he doing there? He was actually trying to find evidence. He was actually trying to do some research to find data, okay? Yeah, sad story. It really is a sad story, okay? So he was in Greenland. This is, I think, 1930. Okay. So kind of a long time ago, but less than 100 years ago, right? I'm just kind of like conceptualizing what's going on here. Less than 100 years ago, he's in Greenland doing research. People thought he was crazy. People thought this doesn't make any sense. This is wrong. He was trying to do research to get some evidence. But blizzard, ouch, bad news. By the time they found him, there was no hope for him, right? Which is really sad. So that's really sad. Blizzard, sad face. And then tell me the rest of the story. If this was the end of Alfred Wegener and the end of his story, would we be talking about him in science class 90 years later, 80 years later? No, like, of course not. What happened, Elena?
30 years after he died, geologists accepted his idea of plate tectonics.
Plate tectonics, right? You heard it, right? That's what they call it. Yeah. So 30 years later, they finally, like, were people just like, oh, I'm reading a book. Oh, here, Alfred Wegener said this. Oh, yeah, it's got to be right. They found evidence that helped to lead to the theory. They didn't call it continental drift, but it is essentially the same idea, right? 30 years after, so it would be 1960. So 30 years after he passed away, okay, geologists found conclusive evidence and developed the idea of plate tectonics, right? It's great. I need that thing, like, because there are like apps where you can do that, right? Like you can talk into something and it makes it sound like that. Totally need one so I can say that when I say plate tectonics. What's that?
I don't think geologists would just get any credit if they're the ones that found the evidence.
Well, so the deeper story. So when you take geology, when you're in college, you will absolutely talk about all of the geologists that did this. There are 2 or 3 of them that are the primary ones, right? Number 1, they don't have an awesome song written about them that I'm aware of. And number 2, part of the reason that we talk about this story in school is because it's part of the narrative of how science works, right? Yeah. So absolutely these other geologists get credit. It's just that does that make sense? And it was like, this one found this thing and this one found this thing, and it all kind of builds to the theory that is plate tectonics. But fair question, right? Why aren't we giving them credit? I will give them credit. I'm not going to list them by name. Yeah. How are we doing? We good? All right. Pull out those Pangea sheets. Yeah, what's up?
I have a question.
Oh, yes, you do have a question. I will try to answer it.
If, like, the continents are still moving, because it says in the video they still move,
Sure.
wouldn't they just crash into each other on the other side if the Earth, like, circle and just, like...
Somebody mentioned that yesterday. I must have been in the other class because I was like, yeah. So absolutely the continents are still moving, okay? Absolutely, there is still crashing going on, right? Absolutely, what happens when the plates move and they crash into each other? Earthquakes, right? Absolutely, and that happens all the time. And we're talking about today.
The continent.
They do, and they are, and they will, and they do crash into each other. Do they move just in a nice straight line? No, right? They move, and it's one of those things. Often when we talk about Pangea, right? We're like, oh, it was Pangea, and now it's this. There was a whole lot of time in between those two things, right? Yeah. So the motion is very, very, very slow, number one, okay? And number two, not only is there motion, but there's also creation and erosion of land. And so it's not like the continents are all just going to move over. Yeah. Yeah. Does that make sense?
Yeah.
So it's a very fair question, but it's not quite that simple. Is that fair? Any other questions before we move on to Pangea? Pull out your Pangea sheet. Okay? So this is what we're going to do, my friends. Some of you did not quite get your sheet done. Some of you did. If you intend to do it, I do not want you to be right now. I actually want you to watch the video. That's part of the game. Okay? But if you did it, you can write stuff down. That's how I'm going to roll with this. I don't do a lot of homework, friends. So I want you to do the homework. It makes this conversation so much faster. We talked about some of this. I do want you to write down these answers because I really, really, really want to make sure they make sense to you. It said, number one, you probably noticed some gaps between the continents after putting your puzzle together. Why don't the continents fit together perfectly anymore? Yeah.
And that'd be like have erosion going on.
Yep. Yep, absolutely. Some of the land erodes away. There's another big one. Why don't the continents fit together perfectly anymore? Did you remember that some of that stuff was gray, right, on the outside? And that land is below water level, right? Sea levels change. And as sea levels change, that makes the coast of the continent change as well. So erosion of landmass and sea level rising. Indeed. What are we doing? Like, not right now. Just not right now. Find another time. Pay attention to what we're doing, please. Okay. Number two is a very important question. I want to make sure you understand it. It did require you to understand a little bit of vocabulary that we didn't explicitly talk about. So some of you may have the prior knowledge that goes with it. And if not, I want to talk about it right now. So this is learning opportunity right here. Make sure you're paying attention, okay? Learning opportunity. Here it comes. There are coal deposits that exist in today's temperate climate zones. If you have not circled that or underlined that or highlighted that, do that right now. Temperate climate zones. These coal deposits were formed from plants that grew in tropical climate zones. You may have not heard the word temperate, but perhaps you've heard the word tropical. What do you think of when you hear the word tropical? Beach. What else? Palm trees. Warm. Humid. Right? These sorts of things. So we will talk about this more later as well. But on Earth, we have different climate zones that exist. Okay? The ones that you probably are familiar with are the tropical. That's near the equator, right? It's warm. Up at the top and at the bottom, you got the polar, the Arctic zones, right? In those you think of cold, right? So you got the cold stuff here, you got the warm stuff here. Temperate, what do you think it means? Nah. The only reason you say nah is because that's where we live, right? It's just what we're used to. It's warm sometimes and it's cold sometimes, and it's kind of medium most of the time. When you compare it to the polar regions and when you compare it to the tropical regions. Okay? So that's what temperate means. All of the United, or almost all of the United States is in temperate, okay? The contiguous 48, okay? Most of Europe, most of Asia is in the temperate, and then down here as well, okay? So think about that. Temperate means not super hot, not super cold. Let's look back here. The question said, the coal deposits were from plants that grew in tropical climate zones long ago. What does this suggest about the movement of the land where the coal deposits are located? What does that tell you? This would be evidence. Yes, Elena, what you got?
That where the coal deposits are now used to be tropics.
Indeed. Does that mean, so I want to reword what you just said. You said where the coal deposits are used to be tropics. So does that mean, so one of the places that I think of coal as being mined is in the Appalachian Mountains right here. Okay, that's where I think about it. So does that mean that at some point in the Earth's history, the tropical zones were up higher? Right. So this continent at some point was located, or this part of the continent at least was located where? In the tropical zone. Okay. So it's not that the zones changed. It's that the location of the continent changed. And that's what gave us our coal deposits there. Okay. And that would be good evidence for plate tectonics, right? So if you haven't written that down, write that down now. And then, it says, how can you explain that the Platysaurus exists on 3 continents and cannot swim? Did you guys catch that? The Platysaurus, 3 continents and cannot swim. What's that?
They always be continents together, so there wasn't a place for them. They weren't in the water.
No, they weren't living in the water, right? They didn't have to swim across the ocean. They just walked across the land. Life is good. Well, I mean, you could also argue that maybe, like, they would have started somewhere, right?
Yeah.
And then it's not like all the Platysaurus live in the same space because they wouldn't have enough food. So they would have all kind of spread out from there. So it's not like they started in one corner of their habitat and then like here we go, we're going to take a big long walk. Like, it didn't happen like that. It's not like The Land Before Time. You guys have seen that movie. It's a good movie. But anyway. All right. Do you remember that one?
Yeah.
Land Before Time?
No.
It's a great one. It's a great one. My kids really like it right now.
Never watched that.
Oh, it's great. I strongly recommend it. All right. Quickly on these questions so that we can move on because it is, it's Tuesday. All right. Other than the continents looking like they fit together like a puzzle, what are 3 pieces of evidence that Alfred Wegener used to support his idea? Now, he didn't have enough to make people say, yeah, of course. But you've watched this. What did you get? Or do you guys need to do this tonight? And we'll talk about these tomorrow. Would that be better?
No, let's just talk about it today.
Raise your hand, because I can't remember because I did this a while ago. Raise your hand if you have this done. Okay. Put it away. Do it for tomorrow. Turn it in with a yellow card. Get your notes out. Notes. Yeah, just like that piece of paper. You can do it with your capture questions if you want. That's fine. We are going to... What's that? It's not directly. Thanks to Alfred Wegener, we have an idea to understand, he kind of led the process to understand where we're at. All right. Scientists, I need your attention up here, please. So at this point, your reconstructing PNG is put away. You got your notes, something to write on, out. We are going to talk about some effects of plate tectonics today and a little bit tomorrow as well. What happened on Friday morning in Alaska? Do you know? There was a big earthquake. There was a really big earthquake. What's that? There you go. See, I have new information. Yep, I know, right? So you're going to write down right at the top of your paper or right wherever you're at, we're going to write Alaska earthquake. And this we can write as in the news.
I thought earthquakes didn't happen in Alaska.
They absolutely do happen in Alaska. So we're going to talk about that right now. Okay, guys. Please stop talking. It doesn't work when everybody's talking. If you have something to say, you can raise your hand. that's cool. If there's a lull in conversation, you need something, that's fine too. But please. So for those of you that didn't know, I'm going to let you know. And for those of you that did know, we're going to talk a little bit about the earthquake that happened in Alaska on Friday. So like literally on Friday morning, it was, I think it was like 9 o'clock their time or 8 o'clock. I can't remember, something like that. But we're going to tell us in just a minute. There was an earthquake in Anchorage, which is the largest city, I believe, in Alaska. We're going to start by listening to a news report from National Public Radio, which is just a news source if you're not familiar, so that you can get caught up with the story.
Alaska was hit by back-to-back earthquakes today. The more powerful one, with a preliminary magnitude of 7.0, was centered just north of Anchorage. Images on social media show roads ruptured and ripped apart. TV broadcasts were knocked off the air. The airport was shut down. Schools were closed. At the moment, there are no reports of deaths. To find out more about what is happening, we are joined by Nat Hers of Alaska Public Media. He is in Anchorage. Hi there, Nat.
Hi, how's it going?
Probably better than your day is going. Tell me where you were today. Could you feel this earthquake as it unfolded?
Yeah, I was sitting at a coffee shop, was just reading a book, and kind of initially just felt like sort of a rumble or a buzz, but then things kind of got louder and things started really shaking and shaking hard, and people were kind of looking around, and then I think, someone went for the door and everyone else went for the door, and, everyone kind of hurried outside. And kind of once things settled down, everyone went back in, and, you could see coffee beans had fallen on the floor. There was plaster that had fallen off the wall onto the floor. And the craziest thing was just looking up and seeing the light fixtures. They were these long light fixtures. And even a couple minutes afterward, they were still swaying back and forth, which was really creepy.
Yeah. And what about the rest of the city? Have you been able to make your way out into the streets and get a sense of the overall state of Anchorage?
Yeah, so I spent several hours after the earthquake kind of meandering around, went to the grocery store. It's a big mess there. Power's out in some places. There's some transformers that are blown out. Kind of the craziest thing that seems to have happened, or one of the craziest things, is there's an off-ramp of a major road in town that just collapsed. And the pavement has sort of broken up into big chunks, and I went over and drove out there and talked to a guy named Chris Wegener, who actually was watching as a car got stranded there. He was in his car.
Started to see everything swaying and lights flashing, and then I watched the car in front of us start to sink as the road pushed out to the left. But I was also, trying to, keep my 7-year-old calm.
So yeah, there's some really major damage there. It's not usable. The car that the person was in is just stuck on an island of pavement, and so that's going to be a pretty major job to fix it.
But give me a sense of perspective, because Alaska is vulnerable to earthquakes. You get them every year there. Is this one big in the kind of sense of typical quakes that you have experienced before?
Yeah, well, I think, the sort of touchstone for all earthquakes in Alaska is the big one that happened in 1964, which was 9.2. And so it's kind of wild to think about that, and honestly a little scary to think about, just because the one today felt like such a big thing, and it was still, many times smaller than the one, 50 years ago.
That's reporter Nat Hers of Alaska Public Media. Thanks so much.
Thanks.
There you go. Okay, so that gives you a little bit of a sense, right? I've also got some pictures that I want to show you just to give you a little bit more context for what this is like. Yeah.
We were just saying that they were just standing there in their car, and you're sitting there, and then the car in front of them just starts sinking.
Yeah. So just a little bit of perspective. I was talking to Mrs. Shamshar about this, and she's from Washington State. And, that's pretty darn close to Alaska. And she was telling me that when she was growing, well, now that she's moved to the United States, to the Midwest of the United States, the idea of a tornado just freaks her out. Like, that is so scary. But to us, for many of us, that's just kind of part of life, right? And, you know, since you were a little kid, we've always done like tornado drills, right? Like where the principal comes on the da-da-da and like tells you it's a tornado drill, blah, blah, blah. When she was growing up, they didn't do tornado drills because you don't get tornadoes in Washington State. You don't get tornadoes in Alaska. Like, meteorologically, it does not happen. But they do get earthquakes. And so they do earthquake drills. So the same idea, just with a different kind of natural disaster, right? Which is kind of an interesting thing. So it's a big deal. It's scary. And like thinking about, if you're 7 years old and you're sitting in a car just driving to school, and then all of a sudden, like your car just like that, yeah, that's terribly frightening. But it's also part of reality in that part of the world. Yeah.
So what do you do during an earthquake?
During an earthquake? That's a really good question. So I think I mentioned to you one time that we felt one here. I looked it up because I couldn't remember when it was. It was September 2016. There was an earthquake early in the morning. It was a Saturday morning, and I was up because my kids wake up early, and like I was just sitting on the bed with them, like reading a story, and like I could feel the earth like move a little bit. It was very weird that I like looked it up because I'm like, something was not normal. And that earthquake happened in Oklahoma, I think. So that was like super far away from us. When you are close to the center of an earthquake, what do you do? Like during an earthquake drill, they're trained to get underneath their desks, right? Because you want to protect your head. So you get under your desk, you get under, whatever you can. Or, hey, Shamshore, can you tell him about an earthquake? She loves earthquakes. Come tell him real quick.
Earthquakes.
Yeah, come quick. So go.
If you're in an earthquake, you want to get, I'm from West Coast, so I experienced earthquakes. You want to get under a desk or a doorway. My favorite story about, you guys do tornado drills all the time. That's normal for you. That is not normal for me. We didn't do them when I was growing up because we don't get tornadoes. We do earthquake drills. So one day I was in math class. I was in high school. The principal comes on the radio. This is an earthquake drill. But we're in math. So imagine your desks in math. Are they very big?
No.
Would a lot of you fit under there safely?
No.
Not really, right? So I had two big football players in my class. And so one of them was a running back. So he doesn't really fit under this desk. So he puts his legs under the desk and keeps his head out. My teacher was like, what are you doing? He was like, my legs are my moneymaker. I don't care if anything falls on my head. So I think it's pretty but the first thing you want to do is get under something that you'll be safe in. So like if you're under a desk, make sure you hold the legs of the desk because the earthquake will make it move. And then you're just under nothing. When the earth stops shaking, you need to go out to like an open space, like a field. And then, because there's going to be like aftershocks or tsunamis, depending on where you are, and you don't want to be like in a place where things can fall on you during that. So earthquakes, super fun. If you ever have questions, come to me.
Super fun, right? Yeah, like, sure, Miss Shamshore. Thank you. All right, so we got just a couple minutes. I want to show you some pictures to put some reality to this, right? So this is literally what happened, right? So stay in Iowa is really so that this is my I'm just using paper to go in.
I stay in Iowa.
So
Literally going to college.
all right, ladies and gentlemen, scientists, I need your attention up here, please. I've got some different pictures, so I just want to show you this. Right, so literally, so tell me about this part of the earth. What is this called? Starts with a C. It's the crust, right? Some of the crust is breaking open. Is this going to break and get through all of the crust? No, it's not really going to go down that deep when you talk about the entire crust, right? Because that's miles and miles and miles deep. But yeah, I mean, that's like a big cavern, kind of scary. Whoa! Let's do another one. There's one from above. So there's the road looking from above, right?
And it's on a mountain.
No, that's literally just the road, the crust breaking. Yeah, so you can see all of these cracks that happen. Isn't that kind of weird? It's crazy, right? Right, that's the question. What do you do? This one I thought was really interesting. So in this picture, there are a couple things that are interesting. One is that you can see the cracks. The other one is that you can see cracks in like the retaining wall. So that's interesting. And there are cracks in the house itself.
You can
Okay.
kind of feel like it's like shifting.
It's kind of shifted. So the thing about living in an earthquake-prone zone is that the building codes are much more specific. They're much more stringent because they do not have to build a building in Iowa to withstand that, right? It's not necessary. What do they have to build houses in Iowa with generally? Basements, right? Basements for safety from tornadoes. But in Anchorage, do they get tornadoes? They don't need a basement, like it's not a thing. But they have to have houses that can withstand the shaking. Yeah.
Is that front porch normal?
No.
I'm gonna go with no.
No, I can't really see it.
It's kind of hard to see in that picture, but I'm gonna go with no. I don't think that really is. That's how it's supposed to look. That's the storeroom from a grocery store.
Oh, nice.
A little bit messy, right? Yeah.
And
And this
the bag of pizza deposit.
that we're not going to judge. But this is why, ladies and gentlemen, you don't want to stay just in any place, right? You get down because stuff is going to fall. This is a school library. I actually have a friend who lives in Anchorage, and she has a 6-year-old little girl, and she was just posting on Facebook that she's home all week. Like they're off all week because they're trying to do all the safety stuff. Picking up the book's not a big deal, but making sure that the ceiling doesn't fall on people, like that's a big deal, right? That's a kind of a scary thing. So, just a little bit more context for all of this. So the red dot is where the earthquake took place, and Anchorage is this black dot that you can see just a little tiny piece of. So the epicenter of the earthquake was very, very close to Anchorage, which was a big deal, right? Again, I felt the rumblings from an earthquake in Oklahoma that was a smaller earthquake than this one, okay? So like that's crazy big. So it was felt all the way up here. So that's the shaking. But then the pink stuff, what's that?
Tsunami.
That's a tsunami. What is a tsunami?
Big waves.
Huge waves, right? That come like feet high, that come and can.
An earthquake that happened like on the oceanic crust.
Well, the tsunami is just the big wave.
You know, since we're
That's
talking
the
about
result.
earthquakes, we should watch the movie.
Yeah, probably not, but we could.
I love
1964.
that.